You ever just get blown away by how much research is going into cancer treatment these days?
It's incredible, right?
Like every day there's something new. This deep dive, though, this one's really got me thinking. We're going deep on a brand new paper, just came out last month, about something called the mitochondrial stem cell connection, or MSCC for short.
Yeah, it's cutting edge stuff.
Really, really interesting stuff. And honestly, you're hearing it here first, folks. This research just dropped September 2024 in the Journal of Orthomolecular Medicine.
People are definitely taking notice.
Oh, yeah. Big time. What I find so fascinating is how it challenges that traditional view of cancer. It's not just about genes going haywire.
It's like this cellular energy crisis at the very heart of it all.
Okay, so break it down for us. What is the MSCC? What makes it so special?
Okay, so picture this. Your cells, they're like these tiny little cities bustling with activity. And every city needs a powerhouse, right?
Keeps the lights on? Yeah.
Exactly. And those powerhouses, those are your mitochondria. Now, the MSCC theory, what it suggests is that when these mitochondria, specifically in stem cells, those cells that can basically become any cell in your body, when they start to malfunction, it sets off this chain reaction. And that can, it can lead to cancer.
So it's like the city's power grid goes down and suddenly everything's chaos.
That's a great way to put it. And the more those mitochondria struggle, the more aggressive the cancer seems to become. The paper actually lays out these 7 key points about this connection. And the first one is a real doozy.
Hit me with it.
So it all boils down to how our cells normally produce energy, right? This process called oxidative phosphorylation.
Right.
It's pretty complicated, but basically the research is saying that when this process gets messed up in stem cells, it can actually trigger tumor formation. Yeah, and those malfunctioning stem cells, they can turn into those nasty cancer stem cells we always hear about.
So it's like a chain reaction, but at the tiniest level imaginable. Wow. So what happens next? The cells are facing this energy crisis. Do they just give up?
No way. They get desperate, they're fighting for survival, and that's where the author's second point comes in. Cancer cells, they're hungry, like really hungry.
Okay, I'm intrigued.
Since they can't get energy the normal way from their mitochondria, they develop this insatiable appetite for glucose.
Sugar.
Yes, and this other fuel called glutamine.
So they're basically fueling their growth with whatever they can get their hands on.
Exactly. They become scavengers, gobbling up glucose and glutamine to compensate for their energy crisis.
Fascinating. So that ties into the third key point of the MSCC, the whole idea that cancer cells are kind of like sugar addicts.
You got it. It's this reliance on glucose and glutamine that makes them so dangerous.
So you're telling me there's a chance we could essentially starve these cancer cells out?
That's the theory these researchers are exploring, and it's pretty radical. The study found that no tumor cells, not even those super resilient cancer stem cells, can survive if they're completely deprived of these fuels.
Interesting. So what's happening in the environment where these cells are growing? It must be crazy.
It's pretty hostile, yeah. The fourth point of the MSCC theory, it describes this harsh environment. Low oxygen, acidic, messed up bioelectricity. That's the tumor microenvironment where these cancer cells thrive.
Sounds rough.
It is.
No wonder they're so good at survival. They're basically living in a post-apocalyptic wasteland.
Right.
So where do we go from here?
Well, point 5, it tackles a big one. Metastasis, cancer spreading.
Right.
The study suggests this happens when those tricky cancer stem cells buddy up with immune cells called macrophages.
Oh, no.
Yeah, it's like they're hitching a ride to other parts of the body.
Those sneaky little... So this whole thing, the malfunctioning powerhouses, the energy crisis, the hostile environment, the great escape, this applies to all types of cancer.
That's the potential game changer here. The authors seem to think that this mitochondrial stem cell connection, it's a fundamental mechanism across the board, no matter what type of cancer we're talking about.
Wow. Okay, I have to ask. If this MSCC is at the root of so many cancers, is there a way to fight back?
That's what makes this deep dive so fascinating. The authors, they actually propose a potential treatment protocol based on this whole MSCC concept.
Okay.
And here's where things get really, really interesting.
Go tell.
They suggest what they call a hybrid orthomolecular protocol.
I'm going to be honest with you. I'm not a doctor. You're going to have to break that down for me.
It's simpler than it sounds. Orthomolecular, it just means using substances found naturally in the body to restore health. We're talking vitamins, minerals, giving your body what it needs to heal itself.
So less about harsh chemicals and more about working with our bodies to fight cancer. I like the sound of that. What exactly does this protocol involve? So we're ditching the harsh stuff and embracing our body's natural defenses. I like it.
Yeah.
But what does this hybrid orthomolecular protocol actually look like?
Well, it's kind of like a multi-pronged attack, hitting the problem from all sides. They suggest a combo of things like intravenous vitamin C, oral vitamin D, zinc.
Okay, so vitamins. Sounds a bit like my grandma's supplement drawer. I'm guessing there's more to it than that.
Oh, absolutely. It's not all about popping vitamins. They also suggest incorporating some existing medications repurposed for their cancer-fighting potential. Things like ivermectin and a class of drugs called benzimidazoles.
Hold on, ivermectin.
Yeah.
As in that ivermectin, the one that's been all over the news.
The very same. But let's leave those other debates aside for now. In this protocol, the focus is solely on ivermectin's potential impact on those rogue mitochondria in cancer cells. Some studies suggest it might actually be able to trigger something called autophagy. It's like the cell's self-cleaning mechanism. Gets rid of damaged parts.
So the cancer cell basically cleans house, and hopefully itself, right out of existence.
You got it. Now, about those benzimidazoles. They're a fascinating group of drugs initially developed as antiparasitics. But some lab and animal studies have shown that they might actually pack a punch against cancer cells, too, by messing with their energy production.
So it's like a 1-2 punch, disrupting their energy and then forcing them to clean up their acts.
Exactly. But hold on, we're not done yet. This protocol isn't just about popping pills. The researchers also emphasize the importance of lifestyle changes, specifically dietary interventions like the ketogenic diet and fasting.
Ah, the keto diet, I knew it. All that bacon and cheese, and now it's fighting cancer too.
Well, not exactly a free pass on the bacon, but the basic idea is that the keto diet drastically reduces your carb intake and replaces it with healthy fats. This basically forces your body to switch its main fuel source from glucose to ketones.
And why is that a good thing when it comes to cancer?
Remember how we talked about those glucose-addicted cancer cells? The keto diet essentially cuts off their favorite fuel supply, starving them out.
That's pretty ingenious. And what about fasting? Is that like taking the keto diet to the extreme?
You could say that. Fasting, whether it's intermittent or for longer periods, has been shown to actually give those struggling mitochondria a boost. It promotes cellular repair, and yes, it can further deprive those sugar-hungry cancer cells. In fact, the study even suggests combining the ketogenic diet with these periods of water fasting, especially for more aggressive cancers.
Okay, now this is where I start to get a little nervous. These dietary changes sound pretty intense. What about those of us who enjoy a slice of pizza every now and then?
And that's where the hybrid part of this protocol comes in. It's all about finding what works best for you and your body. This protocol isn't meant to be a one-size-fits-all prescription. It's more of a starting point for research and, most importantly, a conversation with your doctor.
Got it. Consult your doctor before trying this at home. But I have to say, this research is pretty revolutionary. So we've got the vitamins, the repurposed medications, and the dietary changes. What else is in this cancer-fighting cocktail?
Good question. The researchers also suggest incorporating a couple of other therapeutic approaches, things like moderate physical activity and something called hyperbaric oxygen therapy.
Hyperbaric oxygen therapy.
Oh.
Okay, that sounds pretty intense.
Hmm.
Is that like breathing pure oxygen in a pressurized chamber?
That's exactly it. It's already used for a bunch of different conditions, and in this context, it's about tackling that low oxygen environment we talked about, the one where those cancer cells love to hang out.
So it's like crashing their party by flooding the tumor with oxygen.
Precisely. And there's evidence to suggest that it might also give those healthy mitochondria a boost, giving them a fighting chance.
It's like sending in reinforcements for the good guys. Okay, so we've got a pretty good handle on this whole protocol, vitamins, repurposed medications, dietary changes, and these additional therapeutic measures. But before we dive into specifics like dosages, I think it's important to zoom in on each component individually. Let's start with vitamin C. I always thought it was just for colds, but apparently it's a cancer fighter now too.
Well, vitamin C has been studied for its potential anti-cancer properties for decades, actually. What makes it so interesting in this context is its ability to act as a pro-oxidant in cancer cells.
Wait a minute. I thought antioxidants were the good guys.
Generally, yes. But high-dose intravenous vitamin C, it can actually trigger the production of hydrogen peroxide.
And hydrogen peroxide is not something you want hanging around your healthy cells.
Exactly. It's toxic to cancer cells. Think of it like a Trojan horse, sneaking in and disrupting things from within. And this study suggests that it might be particularly effective at taking down those pesky cancer stem cells. They even cite some interesting findings, like how intravenous vitamin C was more effective at shrinking pancreatic tumors in mice than traditional chemo.
Now, that's what I call fighting fire with fire. What about vitamin D? Where does that fit into all of this?
Vitamin D is a fascinating character in this story. We know it's crucial for bone health, but research suggests it might also have some serious anti-cancer potential, especially when it comes to those mitochondria and cancer stem cells. The research highlights its ability to improve mitochondrial metabolism and even regulate cellular respiration.
So vitamin D is like a personal trainer for our little powerhouses.
In a way, yeah.
Yeah.
Giving those mitochondria the tools and support they need to function better. There's even a case study mentioned in the research about an elderly patient with advanced pancreatic cancer who had unexpectedly prolonged disease-free progression after taking high doses of vitamin D.
Wow, that's incredible. Okay, what about zinc? I know it's important for the immune system, but how does it actually help fight cancer?
Zinc is often overlooked, but it's absolutely essential for healthy cells, including those all-important mitochondria. The study emphasizes zinc's role in protecting mitochondria from damage and its ability to interfere with how cancer cells use glucose for energy, effectively cutting them off.
So zinc is like a double agent, protecting the good guys and sabotaging the bad guys.
You got it. It's about giving our bodies the resources they need to fight back. Now, let's circle back to those repurposed drugs we talked about. You asked about ivermectin earlier. Want to unpack that one a bit more?
Absolutely. Fill me in on how ivermectin is thought to tackle cancer in this context.
So the study really focuses on ivermectin's potential to trigger that self-cleaning process in cancer cells, that autophagy we talked about. It also points out that ivermectin can interfere with something called glycolysis, which is how cancer cells break down glucose for energy.
So it's a double whammy, disrupting their energy production and then encouraging them to clean house.
Precisely. And they even mentioned some pretty compelling findings from animal studies showing that ivermectin was actually more effective at shrinking pancreatic tumors than the standard chemotherapy drug.
Wow, okay, now that's impressive. But what about the benzimidazoles? How do those work against cancer cells?
Remember how we talked about cancer cells relying on glutamine as a fuel source? Well, benzimidazoles, especially a drug called DON, are known to interfere with glutamine metabolism. Basically, they cut off that secondary energy source for the cancer cells.
So no pizza, no glutamine. Those cancer cells are running out of options.
Exactly. And there's even a case study in the research about a patient with metastatic colon cancer who saw near complete remission using mebendazole after other treatments had failed and with minimal side effects.
That's incredible. It sounds like these benzimidazoles are definitely worth a closer look. So we've got the vitamins, the repurposed drugs, the diet. It's a lot to process.
Yeah.
But is it safe?
That's the million-dollar question, and the authors are very clear that more research is needed. However, they do provide some dosage recommendations based on existing research and case studies.
Of course, of course. And it's important to emphasize this isn't medical advice. Always talk to your doctor before making any changes to your treatment plan, folks. So walk me through these dosages. What are we looking at for each component?
Okay, so for intravenous vitamin C, the study suggests a dose of 1.5 grams per kilogram of body weight per day,
Okay.
2 to 3 times a week, specifically for those intermediate and high-grade cancers.
Okay, so pretty specific. Definitely something you'd want to discuss with your doctor. What about those lower grade cancers, does it say?
Yeah, unfortunately, the study doesn't really dive into specifics for low-grade cancers.
Okay.
They stress that any treatment plan needs to be, totally personalized,
Gross.
taking into account the type of cancer, the stage, your overall health.
Right. One size doesn't fit all when it comes to cancer treatment, especially. Okay, so what about vitamin D? How much are we talking?
So for vitamin D, they recommend shooting for a blood level of 80 nanograms per milliliter.
Okay.
And to hit that, they suggest a daily dose of 50,000 IU if your blood level is below 30. If it's between 30 and 60, 25,000 IU. And then between 60 and 80, 5,000 IU.
And I'm assuming regular blood tests would be essential, right, to kind of track those levels?
Oh, absolutely. Got to stay on top of it.
Yeah.
Once you hit that target level of 80, they suggest maintaining it with a lower dose, around 2,000 RUs daily.
Gotcha.
But again, always work with your doctor.
Right. Find what's right for you. Makes sense.
Okay.
What about zinc?
So for zinc, they recommend 1 milligram per kilogram of body weight per day.
All right.
And then once your zinc levels are where they should be, you can usually maintain with a lower dose, like 5 milligrams daily.
Got it. So we've got the vitamin game plan. Now let's talk about those repurposed drugs, Ivermectin and the Benzimidazoles. Those dosages, I feel like those could be a little tricky.
Yeah, you're not wrong. They can vary a lot depending on the drug and the cancer grade.
Right.
So for ivermectin, the study suggests zero point 0.5 milligrams per kilogram 3 times a week for low-grade cancers.
Okay.
Intermediate grade, we bump it up to 1 milligram per kilogram 3 times a week.
Okay.
And then for high grade, the dose can be anywhere from 1 to 2 milligrams per kilogram every single day.
Definitely not something to mess around with on your own.
No. Always consult with your doctor.
Okay, what about the Benzimidazoles, specifically Mebendazole and Benzimidazole?
Right. So for Mebendazole, they suggest a daily dose of 200 milligrams for those low-grade cancers, 400 milligrams for intermediate, and then for high grade, you're looking at up to 1,500 milligrams.
Wow. Okay, and Benzimidazole.
For Mebendazole, they mention a dose of 1,000 milligrams 3 times a week for high-grade cancers. They base that on a case study where patients with stage IV cancer saw some positive results.
Interesting. And what about Dawn, that other benzimidazole you mentioned?
So for Dawn, they suggest using it either intravenously, intramuscularly, or orally, with doses ranging from 0.2 to 1.1 milligrams per kilogram each day.
Okay.
The study does mention that benzimidas are generally easier to get a hold of than Dawn,
Right.
but Dawn might be super important for those aggressive metastatic cancers that really rely on glutamine for fuel.
Yeah, it's like having all these different tools in your arsenal, depending on the specific type of cancer you're dealing with.
Exactly. Now, moving on from medications, let's talk about something a little more, shall we say, accessible.
Yeah.
The ketogenic diet. They recommend aiming for around 900 to 1,500 calories a day.
All right.
Super high fat, very low carb. And remember, for those intermediate and high-grade cancers, they recommend combining this diet with periods of water fasting, talking 3 to 7 days.
Intense. No cheat days on this plan. I'm
Oh,
glad.
probably not. But let's
Yeah.
be real. That kind of dietary change, it's a lot to ask of anyone.
Yeah.
Again, this is where working with your doctor or a registered dietitian is crucial.
Absolutely. Find that balance.
Yeah. They also recommend incorporating some moderate physical activity, things like cycling, running, swimming for about 45 to 75 minutes, 3 times a week.
Okay. And for those who might not be able to handle that kind of, intense physical activity.
They suggest looking into hyperbaric oxygen therapy 2 to 3 times a week at a pressure of 1.5 to 2.5 ATA for 45 to 60 minutes per session.
Got it. So much to consider, so many different possibilities. You've really emphasized the importance of individualized treatment throughout this whole deep dive. Can you remind us why that's so crucial?
Because every single cancer is different, just like every single person is different.
That's true.
This protocol, it's a fascinating starting point,
For sure.
but it's not a magic bullet, It's all about working with your healthcare team to figure out what's best for you, your specific situation.
Absolutely. And it's important to remember this research is, like we said, it's groundbreaking, but it's still in those early stages, right?
Totally. More research is definitely needed to confirm just how effective and how safe this approach really is. But what's really cool is that it opens up this whole new way of thinking about how we treat cancer.
Absolutely.
This whole mitochondrial stem cell connection, it could be the key to unlocking treatments that are more effective and less toxic down the line.
It's like we're on the verge of this whole new frontier in cancer research. It's amazing. As we wrap up this deep dive, what's the one big thing you want listeners to take away from all of this?
I'd say just keep asking those questions. Keep being curious.
Yes.
And if something sparks your interest, dive in, learn as much as you can. You never know, you might just stumble upon the next big breakthrough.
Love that. Knowledge is power, especially when it comes to our health. That's it for today's deep dive into the world of the mitochondrial stem cell connection and a potential new approach to cancer treatment. And, as always, please consult with your healthcare provider before making any changes to your treatment plan.
Until next time, stay curious.
And keep on diving deep.